Summer thunderstorms supply most of the rainfall for the vast growing regions of the American Midwest. Worldwide, there are several thousand every day. Too often, these towering storms release a barrage of hail that mows down crops and batters property. "10 minutes of hail can reduce a year of farmers' toil to stubble." Every year, U.S. agriculture loses about $300 million to hail, greater than the damage from tornadoes. Worldwide losses are about $1 billion annually. In the late 1960s, the Federal Council for Science and Technology recommended that the National Science Foundation investigate the feasibility of hail suppression. NSF asked the National Center for Atmospheric Research to join its facilities and technical skills with those of university, government, and private research organizations in a combined research project. As a result, a 5-year program called the National Hail Research Experiment began in 1972 in an area of northeastern Colorado called Hail Alley because of its many destructive hailstorms. Near the town of Grover, the most advanced scientific tools have been gathered for the complex task of learning more about hailstorms and determining whether practical methods to suppress hail can be developed. One of the most important tools is high-powered radar, which probes into storms to determine how precipitation develops, how much moisture is in the cloud, whether hail is growing, and how air currents move. Dual wavelength radars developed by the National Center for Atmospheric Research, the University of Chicago, and the University of Illinois are the most advanced of their kind. The radars have provided the first direct measurements to distinguish between rain and hail in clouds. Each day of research activity begins with the launch of weather balloons by Air Force crews.
Relay!
Radiosondes send back information to help predict weather conditions for the day. Surface and low-level wind patterns show whether moist air is likely to flow into the area and contribute to storm development. Teletyped data from the National Weather Service adds to the weather analysis. The scientists compare this information with measurements from their own network of ground instruments to see how local weather fits into the larger regional patterns. All information is recorded or sent to a computer for processing. The data records provide detailed case histories of each day's events. About noon each day, the staff meets to plan the day's operations and review yesterday's events.
Not only affected the leading edges of the wings, but came back up over the top of the airfoil when he went down to a lower altitude to let the ice drop on.
The storm had been seeded, the one he was working with.
The dots on here would indicate that it was seeded in that last penetration.
Okay, thank you, Dennis. I should have added that we had maximum radar Z values of 62 in this storm and tops of about 48,000.
The scientists review measurements of rain and hail over a 600 square mile protected area, which contains 400 rain and hail measuring stations.
Southwest corner to the east. Sounding looks pretty good today. I gather that all
After the briefing, the operations director initiates a 6-way conference call with participants at other locations. He reviews weather conditions and coordinates planning.
And today is a potential seed day. At 12 o'clock sounding shows pretty good potential. For today, we have 12 gram per kilogram of moisture and convective temperature of about 78 degrees.
Guy, this is Brent. It looks like with those clear skies out there, we should get plenty of surface heating taking place. I don't believe we're going to have any trouble getting convection started today.
Yeah, Guy, this is Fankhauser. We'd like to know what you'd project for cloud bases off those noontime soundings.
The cloud base for today will be just about 10,200 feet, the -5 degrees level at 17,500 feet, and the -30 at 28,000 feet.
The national experiment has prompted development of special instruments needed for key phases of the study. One instrument is an electrically heated evaporator, which measures the amount of condensed water inside clouds.
That's a wide beam blocked.
Yes, that's why
Okay,
it's
I'll
being
block it there. Let's see what it... About 2.5 volts. Let's go to the...
Another instrument, called a dysdrometer, measures the sizes and numbers of drops as they pass through a laser beam.
Pretty good. It's only about 0.2 of a volt.
The evaporator is mounted with over 20 other instruments on a T-28 aircraft operated by the South Dakota School of Mines and Technology. The T-28 is armor-plated to withstand the bruising force of hail and penetrates the interior of storms where no other aircraft can fly. The T-28 has already made over 100 of these turbulent flights.
Delta, go. 6 Delta advised prior to changing altitudes. We've got IFR traffic 10,000 with 10 o'clock T now 7 miles.
Half a dozen other research aircraft and several seeding aircraft participate in the experiment. They circle storms from 2,000 feet above the ground to 40,000 feet, studying processes that change constantly as the storms develop.
Yeah, and I see this updraft shelf here. We're not quite in it now, but it must be pretty strong there. And I don't know whether you can see it or not off to about 1 o'clock. Last pass around about here we had one, but nothing quite like that.
The storm's updraft is a key to the storm's intensity and size, and perhaps its Achilles heel. The scientists theorize that cloud seeding agents released into the updraft and swept into the core of the storm will prevent the growth of large, damaging hail by converting the available moisture into many small and harmless pellets. During cloud seeding, silver iodide seeding agent will be injected into the clouds by flares burned beneath the aircraft or by rockets fired upward from the aircraft. Flights are coordinated by the Federal Aviation Administration, and all other aircraft are instructed to avoid the special use space. As the aircraft probe the growing storms, activity at the ground also intensifies. A new sequence of radio sondes helps to determine how fast the winds are bringing storms into the area. Observers in the aircraft guide ground teams to key areas beneath the storms.
Balloon away.
Highly equipped mobile ground units measure weather and air composition and chase hailstorms to collect rain and hail samples. Operations control at Grover is the nerve center for all activity. When a storm of a certain intensity threatens the protected area, the operations director declares a hail day. A high return of radar signals from the storm indicates dense rain or hail accumulation above a certain temperature level. Values above 50 decibels, or 50 dBz, are an almost sure indication of hail large enough to fall to the ground.
Okay, tell me when to go through the storm. Okay, you're right on it. Okay, that's 5-1. 5-1. Alpha, it's 5-1, 51 dBz above the -5 level.
083 is located at Gil 07036.
Guy, the reflectivity at the southern edge of that cell is 51 dBz.
51.
West side of the storm, he's going to go outside the airspace, and it looks like we're going to have to climb him from 35,000 up to about 37,000 feet.
We now have a 51 dBz. This is a hail day. Let's start seeding, Tony.
Once a hail day is declared, a decision is made whether or not to seed that storm and any other threatening storms that day. Random days are chosen for seeding to allow comparison of seeded and unseeded storms. All data, computerized and stored, assist the present research and long-term analysis. Statistical analysis of the occurrence of hail over several years is needed to determine whether the suppression attempts are successful.
Tony, we will need one more cloud seeding aircraft on this northern storm. Could you call Greedy, please?
Roger. 4-3 Yankee Grover.
Grover, this is 4-3 Yankee, go ahead.
Roger, 4-3 Yankee. Would you contact Greeley, have them send one more seeding aircraft, please, and have him contact Grover on 164.7.
We should have a cedar at about 35 degrees, 35 miles. From the look of this echo, the updraft should be on the southeast side.
We're still too far away to get any recordings of the cloud base activity, but we expect to have a good cell when we arrive.
Control track, I have Zero Mike Hotel on Beacon track. I show him at 22,000 feet. I'm standing by for penetration.
That'll be fine. He's going to complete his box pattern on the southwest corner.
We're approaching this cell from the southwest at this time, and the tops appear to be very hard and building.
Proceed 035 slant 50. That should put you on the southeast quadrant of this cell. You should find your maximum updraft area in that region. Be advised it is a hail day, and you may commence seeding as soon as you have located yourself in the updraft.
Each flare burned in the storm's updraft provides billions of tiny particles, which breed smaller hailstones than those produced by the unseeded storm. Seeding injections at the right time and place are crucial and depend on information from the radar. An important part of the experiment is to study the physical, environmental, and social consequences of storm modification. Measuring downwind effects of cloud seeding and analyzing silver iodide in plants and soil contribute to these broader goals.
Control track, the cell that we've been working is now at 045 slant 60. The tops are declining. They're down to about 42,000 feet.
Seeding continues as long as the storm threatens the protected area. The radar monitors changes in liquid water content, hailstone sizes, and other evidence of probable seeding effects.
The cell is holding at about 46 or 47 dBz, Guy. The southern cell looks as though it's moving out of the area and will no longer be threatening.
Okay, Tony, we have 083 on the south cell. I don't think that we'll need him much longer.
083 Grover. Be advised the cell you're presently working is tracking away from the protected area. You may now return to Greeley Base.
Field crews work into the evening to evaluate the effects of the storms that have come and gone. Inside the rain and hail collectors is a record of the intensity, duration, extent of precipitation, and the sizes of hailstones. The student crews also record visual and photographic observations. Besides the ground, aircraft, and radar measurements gathered from each storm, the experiment includes research on special topics. Some are contributing to mathematical models of hailstorms. The ability to simulate the behavior of thunderstorms in the computer will be the final measure of our scientific understanding. The National Hail Research Experiment thus combines a rigorous scientific investigation with practical goals. If hail suppression appears to be feasible 5 or 10 years from now, it will be based on solid scientific foundations and on responsible conclusions about its benefits to the nation.
Hey, we got some pretty good damage on this one.
Shows some good activity here.